Okay, this is just a quick review on how to calculate acceleration. Remember that acceleration is the rate at which velocity changes. And so in science, whenever we say the word rate, what we mean is we're referring to how much time that takes. And so to calculate acceleration of an object, you just need to know two things: how much the velocity has changed and the amount of time that it takes for that to happen. A little triangle in the front there is delta, and it just means change in. Another way to write that is you can say the ending or final velocity minus the initial velocity divided by the amount of time it takes. So let's take a look at an example here, and we'll go through it. So here's an app that we've used before in class. If we have this little guy here, we'll pause it real quick. If we have him push a force on it and I hit play, what's going to happen is the crate will go up to speed. And then if we stop that, we can see how much the velocity has changed by, and if we started the stopwatch on the right, we'd be able to get the acceleration. So let's just start that over. Put values on there in speed. We will pause it. I don't know, put 200 or so, just a little under. There we go. Newtons on it. Then what I'm going to try and do is start both the stopwatch and the guy at the same time. So 3, 2, 1, go. All right, so the velocity is changing, the object is accelerating, and we're going to take a look at how much time it takes to get to top speed. So he fell off right there. He went from 0 to 40 meters per second, and it took him 8.65 seconds. So remember that number, 8.65. If we come back over here, we can now go ahead and put in our numbers. So the final velocity was 40 meters per second. The starting or initial velocity was 0 meters per second. The time was 8.65 seconds. And so to calculate the acceleration, we just have to take 40 meters per second divided by 8.65. And let's bring up a calculator to do that. All right, so the answer would be 4.62. So in this case, the acceleration is 4.62 meters per second, and sometimes we write that as meters per second squared. All right, it's just that simple. So it's the change in velocity divided by the amount of time it takes for that change to take